Good morning, everyone, or good afternoon, depending on where you are. Thank you for joining us today. My name is Marissa Waterman, and I'm the Marketing Director here at American Academy of Environmental Engineers and Scientists. We're so excited to be doing this webinar today with Mark McDaniel. Mark's the manager of the Solid Waste Department's Energy Recovery Section at Los Angeles County Sanitation Districts. Today, Mark will be discussing the collection and treatment of food waste to reduce methane emissions. Before we get started, I just want to mention that you'll be able to message your questions at the end of the presentation. Once the interview is over, you'll be able to type your question into the attendee chat on the left-hand side of your screen. We'll also share Mark's email address so you can email him directly with any additional questions you may have. Okay, let's get started. Good morning, Mark. Thank you for joining us today. We're ready when you are.
Okay, great. Good morning, everybody. Thanks for coming to hear about this project that we've been working on for over 10 years now, and we've taken it from a brainstorming idea to through lab work to a fully commercial program. And bear with me. Okay. Get the slideshow started. Okay, so again, as I mentioned, the topic is methane emissions, and that is largely the driving force for our food waste program. Marissa talked about my background, my current job. Just want to mention I've been doing environmental engineering for 42 years. A lot of my topics here are wastewater related. I am not a wastewater guy, but I've picked up enough to get by. My background is environmental and mechanical engineering. From UC Irvine, board certified environmental engineer, and it's just, you know, a plug for environmental engineering. In 42 years, there's still new challenges and new environmental issues to address. And from my 20 years in NOx control at power plants, we saw emissions go from 800 part per million NOx now down to 3 parts per million NOx. So we're making progress and still finding new things. I'll talk about who we are as an agency. Why do we need to recycle food waste? History and overview of our program. Where we are now. Throughout the program, I'll include technical details and lessons learned rather than wrap those all up at the end. So keep your ears out for those. Plug for the Academy, the sanitation districts. We have 30 employees who are board certified. We've won 13 grand awards, 17 individual awards. And actually, 2 of our grand prize awards will be covered here. One is the food waste program that we won an award in 2016, and our energy management program we won an award for in 2012, which includes our digester gas-fired power plant at our largest treatment plant, and that's the photograph at the bottom. Who we are. We do wastewater and solid waste management for basically the Los Angeles County, except for the city of Los Angeles and the mountain and the desert areas. The Joint Water Pollution Control Plant you see down at the bottom there is the plant where we are co-digesting the food waste, about 280 MGD with 24 digesters. We have a fairly unique system in that we have all these upstream water reclamation plants that make reclaimed water from sewage, but do not treat the solids. They put the solids from the treatment right back into the sewer. So JWPCP, or I'll call it the joint plant, is treating the liquid stream that comes to it, plus the solids that have been put in the sewer from all of these other plants. On the solid waste side, you know, it's a different activity. It's also a different business that factors into our food waste. On the wastewater side, we're like a municipal utility or a government monopoly. You want to get rid of your wastewater, it has to come to us and we charge you the cost of service. On the solid waste side, you know, we got into the business back in the 1950s at the request of local governments. But we have to compete with private operators in almost everything we do. We do not collect or haul any trash, but we do help our cities and their haulers dispose of the trash, recycle the trash. So we operate 2 active landfills, 4 closed landfills that we maintain environmental controls. We have 2 MRF as a material recovery facility and transfer station, 2 more transfer stations. The Puente Hills MRF you'll see here in the southeast end of LA County is where we're processing the food waste. So why do we want organic material out of landfills? The direct, there's a legal answer. Apologies for skipping on that. California has Senate Bill 1383 that was passed several years ago. It targets short-term climate pollutants, which are primarily methane, and one of the major sources of methane in California is landfills. It requires that 50% of organics be diverted from landfills by last year, but enforcement doesn't start until next year. And then 75% by 2025. I could do 20 minutes on all the California laws. Every state has various laws, but basically that's a driver that our member cities have to meet. Technically, landfills leak. Even well-designed landfills leak. On the right here is a cross-section of a modern landfill and the environmental controls to collect any groundwater, make sure it doesn't get into the soils, make sure it's collected, doesn't get in the environment, a gas collection system. But even, the best numbers I've seen are 98% collection efficiency. The default EPA number is 70% collection efficiency, and I think there's certainly, there are probably landfills that aren't operated that well. Plus, it's in there for decades. We are still maintaining landfill gas collection system on a landfill that closed in the early 1960s. So your apple core in the landfill is going to outlive you and your children probably. Advantage of putting the organics in a digester is they don't leak. They're a sealed vessel, and typically 15 to 30 days the reaction is done. This is a photograph of a digester. It looks like in the foreground, the 2 round digesters are actually the test digesters for the demonstration program I'll speak about later. These are about 3.5 million gallons. You see about 20 or 25 feet above the surface. They actually go another 20 or 25 feet below the surface. How a digester works, I like to use the phrase, it's a 4 million gallon cow's stomach. There are 4 classes of reaction. By coincidence, a cow has 4 stomachs. I don't think their stomach has one microorganism in each one. But basically, these microorganisms live in the digester. They feed off the digester fuel. They're all mixed together. We don't have 4 sequential digesters. So basically, one bug eats the fuel, makes the food for the next one. When it's all done, you've essentially taken food and created methane and carbon dioxide. Just a magnitude of how much food waste is out there, about a third of trash is organic and about a half of the organic waste is food waste. So roughly 1/6 of the trash stream is food waste that can be potentially recycled in our system. These are photographs of kind of what that looks like. And this slide shows the history of our program, and I'm going to touch on each of these. So this started, with actually a brainstorming idea in a section meeting, conversations, direction, go ahead from our management to look at, we're an agency that does wastewater. We do solid waste. People are talking about digesting solid waste, getting organics out of the landfill. We ought to be involved. So we did feasibility studies to identify what works for us, bench scale lab work to make sure, physically it works, a full scale demonstration program so we would know any impacts on operation and commercialization and build out, and energy recovery projects. We started our first a few months ago and have more coming. So the feasibility studies, what are the technologies? I'm using the phrase dry versus wet. Other phrases would be high solids and low solids. What feedstocks can each technology digest? What's the best fit for the districts? Again, we're an agency with certain infrastructure, with certain goals, with certain financing mechanisms. So what's the best fit for us? So this involved, a lot of, looking at what's out there, technology reviews, meeting with people, site visits. So, after a year, we were pretty expert in this. One option is dry digestion or high solids. Basically, it's something that has to be pushed. And it's best if you have a lot of green waste because it's hard to push sloppy liquid waste. Compared to a wet AD system, it tends to have a larger footprint. There's lower gas production because the green waste doesn't digest like food does. There's more residual material. And this is a good technology. There are 3 operating facilities in Southern California using this technology. Actually, my hometown, I put my food waste in my green waste bin, and it goes to a facility like this where it's digested, and they make methane to fuel the garbage trucks that pick up the trash at my house. Looking at wet digestion, this is from a wastewater side more what we're used to, but there's also dedicated digestion systems for food waste and organics. It's best if you don't have green waste because the green waste, again, does not digest that well. You can get better mixing, you can get more biogas, you can control the odors, lower O&M costs. As a subset of wet digestion, do you do a standalone food waste or solid waste stream digester, or do you co-digest with sewage sludge at a wastewater treatment plant? And that's basically what we focused in on. Advantages of co-digestion: the digester's there. In a lot of cases, you'll already have energy recovery equipment, so you may not have to build new equipment to monetize the gas. CASA, California Association of Sanitation Agencies, did a survey. Our wastewater treatment plants in California can handle 75% of California's food waste stream. That's a pure numbers game. It's physically not easy to get there, and it's actually logistically, legally, commercially not easy to get there because they're completely different markets operating in kind of different worlds, solid waste and the wastewater worlds. Concerns and challenges on co-digesting. It's got to be clean. We can't put trash into our sewage plant, and it may not be intuitive, but digester at a wastewater treatment plant is actually pretty free of contamination because you've removed everything in the front end of the treatment plant before the solids get there. There was concern early on about the impact of residuals on biosolids. You won't hear me talk much about that in the rest of the presentation because we concluded that there was none. There was nothing that we could see. And most importantly, treatment plants have an important public health mission. They're the utility that, just can't, we don't tolerate outages. We can't have a discharge violation. We can't have a sewage spill in the streets. So we, in the solid waste department, we can't come in as barbarians at the gate and impact their operation. We have to work with them and make sure that whatever we do to digest food waste does not impact the treatment plant operation. So our conclusions is that the co-digestion lets us use the existing infrastructure, that we can digest source separated and processed food waste, FOG, that we cannot digest green waste and mixed waste. The other part of this is that we concluded we do not want any solid waste processing at our treatment plants. We want to keep the facilities separately. So now it looks like the concept can work. Before we put this food waste in our digester, we want to know how much to put in. We want to make sure it's not going to kill the bugs in the sludge. So we have a large and very experienced wastewater research group. They have a 10-liter digester that basically simulates what happens in a large scale digester. They basically every day they add a little bit of sludge, they take a little bit out, they collect samples, they meter how much gas. So we can look at essentially the basic science. You know, how much food waste creates how much gas? How much food waste can we put in before we start to disrupt the uh, biology of the digester? So we got those results. I'm I'm free to speak to engineers and scientists. I don't have to apologize for my chart, but basically, we determined that about 30% food waste to sludge on a solids basis, which is about 9% on a volume basis, was optimum. We'd get a lot of gas, and we didn't push the point where we would disrupt the basic operation. So this chart is some of the raw lab work on liters per day of gas produced. The blue on the low is the control digester, and the optimal rate of 30% food waste on a solids basis doubled the methane. So we've got the parameters, and we know how much food waste we want to add, and we know it's going to work. In parallel, other people were looking at digesting food waste. Waste management, the green truck people, I think they're the largest waste collection and processing company in the nation. They had been looking into their own food waste because they see this as something that their customers needed, and they were looking at wastewater treatment plants as a place to offtake their slurry. So we negotiated a demonstration program with them that ran for 4 years. Basically, 61 diverted tons of slurry per day of garbage, 61 tons of food waste diverted from a landfill, which is equivalent to 83 tons of slurry received. We put it into a test digester at the optimal feed rates, and both of our teams monitored this, and the program ran for 4 years. A few details, just going back, this was at our joint water pollution control plant. This is south of downtown LA. That's the Harbor Freeway running along just below the plant. That's actually running north-south. So some of the numbers there, we have the existing biosolids, we have the digesters, they have an existing power plant that uses the gas that they create, and they de-water and truck off, I think, about 1,300 tons a day of biosolids. So that's where we're taking the food waste. Waste management designed and built this slurry receiving system. You can see the four 10,000-gallon tanks. You can see a tanker truck that's loading into one of the tanks, and these tanks are basically, mixed. They serve as day tanks. To the left, you can see the edge of our test digester. We actually put pipes underneath the street. You can see them going up the side of the digester and added at the target feed rates. These are the parameters for our testing. One of the first questions is, we're going to add 30%. Excuse me for a second. We're going to add 30% on a solids basis, or 9 or 10% more liquid. Do we take that away? Do we put in 10% less sludge, or to add it on top? And our decision was to add it on top. So you can see the 205,000 gallons a day of sludge in both. We added 20,000 gallons a day of food waste. You can kind of see the numbers, the percent solids, and here again a key number here for our impact on the treatment plant is hydraulic residence time. Our baseline is 18 days. The legal minimum is 15 days to make biosolids. Adding the extra liquid reduced our residence time by 10% to 16.4. So basically, we've gone from 18 days residence time to 16 and a half, and 15 is our limit. So we are using half of the spare capacity of the digester. And in the long run, if plant flows increase, if food waste flows, food waste feed rates increase, that ultimately could be a trigger to require more digesters. For right now, the plant has plenty of digestion capacity for the 5 digesters that we plan to feed right now. It took a while to get enough food waste. This was a voluntary program. Waste Management is working with customers who basically would need to pay extra to have a separate organic collection. It's extra work for their people, and there's no regulation yet. So it took a while to ramp up. The customers are people like, entities like Hilton Hotels, Angel Stadium, my alma mater, UC Irvine, cafeterias, grocery stores, produce warehouses. So they ramped up the customers. We did hit the target tonnage, actually exceeded it a little bit by the end of the 4 years. And the key metric on gas production is that as we, the blue is our baseline digester, the red is our test digester. And as we ramped up our food waste feed rate, the gas production followed our predicted curve from the research identically. So that confirmed we got more gas, and it confirmed that this test digester is a great tool for predicting what's going to happen. The key results from the demonstration program, the handling and storage systems worked as designed. Usual bugs with any mechanical systems, but we got those worked out. No issues on treatment plant operation. The biogas production increased as expected. And the last 2 items I'll go into a little bit more detail. The odor control systems worked well. Food waste contamination, and this is glass, plastic, grit. It did build things up in the digester. The cost was 75 cents per ton. The extra cost to clean this grit was 75 cents per ton of food waste slurry received. So it was a cost, but it didn't really impact operation of the facility. Mention the odors. If you saw from the earlier slide, we're in the middle of the LA metropolitan area. We have neighbors on all sides. We have a goal to have no odors ever detected off-site. And we work, our plant people work very hard for that. Food waste is a phrase, odorous even by the standards of a wastewater treatment plant. This smells like vomit, to be honest, and so it's a very offensive smell, and we certainly can't have that going out. The first key thing to help control the odors is that we're not really venting this stuff. We're loading it from a sealed truck into a sealed container. The only air that vents is when you fill the tank and the air vents out. And we tried a few things, and our wastewater research group came up with the simplest and most effective was just 55-gallon drums of activated carbon. As the tank fills up, the air goes through there, and no odors come out. We learned some things. There were some odors from vents on the trucks. We learned that we connected the vent pipes on the trucks to our odor control system. Probably the most concern is if there's incidental spillage. Again, we clean it up right away. We're far enough from the boundary of the plant that we're not getting the odors off-site. But those are the key odors. So we view that as a problem that we know how to solve, and as we build out our infrastructure, it's key part of this. The digester cleaning. This is the inside of a digester. You can see this. It is a months-long process to clean the digester. You can see that's not even a figure of a man. That's a literal man there with a fire hose loosening this material up. So the more grit and debris we get in the digester, that means that cleaning takes longer, and it means it costs more to get rid of. But at the levels we had, it's not a deal killer. So we know it works for full scale. We got the go ahead from our upper management and our board to develop the commercial program. This is again to serve our member cities. The 4,000 tons generated in LA County, we can handle On the processing, 165 of that. The digestion today, we're doing 250 to 350 tons capacity today, and ultimately to go up to 615 tons. So we view ourselves as a key part of the solution for our member cities, and we moved forward commercializing things. So three main areas in our solution, we've touched on pre-processing the food waste so it can go into the digester, digesting it, we've touched on, and then what to do with the energy recovery. Again, the post-treatment, the fertilizers and composting, the sludge solids from the food waste were really not even measurable or detectable in the total amount of biosolids we have at the treatment plant. So we've got to pre-process it. Number one, we can't put garbage in the digester. We wanted to have capability ourselves to serve haulers that use our facilities. And there's also, again, it's a private industry. There's a lot of other people out there hauling trash, hauling food waste, processing food waste. So we are one of 9. Our solid waste side is one of 9 suppliers bringing food waste to the joint plant. For the last year, we averaged 30 tons a day at our own facility, 230 from 8 different outside suppliers. And everybody uses different technologies. I'm going to go into details on what we used. This is a slide of our Puente Hills MRF. This is a large 4,000 ton per day transfer and recycling facility. There's a big sorting line in there. There's areas where we just move trash from one truck to another, and in a corner of the plant we set aside for food waste. So we need to go from this, which is source separated food waste, and you look at the truck and that doesn't look too bad. You look at what's on the floor and it's a little messier, and we've got to get all that stuff out of that and get it into a tanker truck, largely contaminant free, to take down to the treatment plant. We looked at 2 technologies. One is a filter press, that described as a garlic press model. Energia market is the one that's the big player in California. They market a system called the Orex, and basically you put a load of trash in, you squeeze it out at really high pressure like a garlic press. The organics come out the other way, and we tested that using actual trash and food waste coming to our MRF. The other is a hammer mill or bioseparator, and basically it's a blender inside a cylindrical screen, and it squeezes the organics out. We chose the DOTA bioseparator. We liked both technologies. We had experience with the DOTA. That's what Waste Management used on our demonstration program. And at the time we made the decision to go ahead, the Orex was not commercially available or proven in the United States. And European technology is great, but we tend to be conservative, and we want to see stuff that works here before we commit to it. This is a shot of the bioseparator. So on the left is the feed hopper. There's a rotating auger that moves back and forth so that the stuff you saw on the floor gets scooped into that. 2 bioseparators. The first one has screens of 15 millimeters. What comes out through that then goes through the next one, which has screens of 8 millimeters. And that, again, is a lesson that we learned from the demonstration program that Waste Management learned and shared the information with us. Inside the bioseparator, you can see on the left, that's the hammer mill that spins around at high speed, grinds up the feed, squeezes the organics out through those 15 millimeter holes. It drops to the bottom, that gets pumped to the tanks. The right hand picture is what that looks like from the outside. So that looks really nice. Here's what it looks like after you run for a few hours. Those plastic bags really build up. So this is it runs great, but it takes about an hour of cleaning for every 2 hours of operation. So that's again, a lot of the lessons learned on the mechanical systems. Our solid waste operations people run this, and they've learned all the tricks of the trade in the 2 or 3 years they've been running it now. Currently, we're doing about 10 to 15 truckloads a week. This is a truck loading in from the storage tank in our MRF. And the second step is co-digestion. And again, we have covered this earlier, basically the same digesters we had before, but the demonstration project is done. The equipment is gone. We need to build new receiving facility, and we need to learn those lessons and develop specifications. We've got to protect the stable treatment plant operation, and we want to minimize our O&M expenses. We had a couple of decision points to make going in, beyond, making sure everything, works. One is, we have in our 9 suppliers, we probably have 4 or 5 completely different technologies and models of how they're collecting food waste and processing food waste. And did we want different specs for different technologies? And our answer is no. Everybody's got to meet the same specification. Later on, I'll talk that we have the option in between the demonstration project and the full build out of equipment to put it in the digester. We've been taking material at the headworks of the treatment plant, and the treatment plant can certainly handle a higher contamination level than the digester can because it's designed to take out solids and grit. But we decided, no, we're going to make it simple. We're not going to have 2 markets and 2 suppliers. So you want to bring your food waste slurry to us, these are the specifications. We look at them every year. We fine tune them every year. These are the ones I'm showing here, things that are kind of digester health, solids, volatile solids, electrical conductivity, make sure there's not a lot of salt in there. The volatile acids was a key concern. So these are basically largely for pump it and keep digester health. There's a whole bunch in the middle. You might have noticed the previous slide ended at 11, then went to 27. There's a lot of trace metals and other things in there. But these are the ones that are geared toward basically contamination, operation of the pumps that are going to get this stuff into the digester and filling up the digester. So these are specifications that we've put in. We've actually had to work with some of the haulers and labs to find methods that apply to this. So basically, don't disrupt the digester, don't fill it up with grit, or our specifications. How do we ensure compliance? When we talk to a new hauler, we meet with them, we discuss what they have. Pre-COVID days, we'd go out and visit the site and talk to them, and we'd make sure that everything was tested. Every load on delivery is tested for pH and conductivity. Samples from each load, the truck driver drops off a bottle with our operator. Those are archived, refrigerated, and spot checked. And again, it's kind of trust with verification. If you come from the landfill side, there's a lot of people who will try to slip in a load of fluorescent bulbs buried in the trash and do that. Because you've got a lot of small contractors, individuals. These are long-term business relationships. We do not expect anybody to intentionally violate the specs because they know if they did that we're not going to work with them anymore. So we have not had any problems. And nearest to a problem, one hauler called and said, "Hey, my load's out of spec on pH. Will you take it?" And our answer was no. That's kind of as close as we've come to issues. So where do we receive the food waste? The demonstration program was a slurry receiving station straight to the digester. That's ideal. But between the end of the demonstration program, when waste that ended, the equipment was dismantled and taken away, and full commercialization, we still had customers. We still had people bringing food waste. So the idea is that we can put it in at the existing plant headworks, and it's easy. We have a liquid waste disposal station where trucks come in with mostly septic waste and unload. And it had the advantage, it's immediately available. There's no capital. The concerns are you're putting the food waste through the treatment plant. You're going to get our modeling says 40% less gas than if you put it straight to the digester. The other is you have lower capacity overall because this food waste impacts every step of the wastewater treatment process, and there's a lot of nuances there. So the liquid waste disposal station is a short term, it's an interim solution, it's extra, but we are focusing in on the slurry receiving facilities. Our original design was, a $9 million design. We looked at the finances of the program, the market, went to the treatment plant, had people really thinking of creative solutions, and we came up with a simpler design using what we could have, and this is going to cost us about $3 million. So our SRF slurry receiving facility 1, which you see a picture of here, which is actually on the same concrete pad as the tanks you saw for the demonstration, will handle 2 digesters. Slurry receiving facility 2 is under construction. We'll target is to be finished this summer. 5 digesters, 415 tons a day, and this was designed and built in-house. And again, that was a key part of the savings and a key part of getting things done quickly. This is, before I leave the treatment works, this is what the liquid waste disposal station looks like. They just hook up the hose, drop it straight in that manhole, and there's I think it's a 14 or 16 foot diameter sewer main there that goes right into the headworks of the treatment plant. So the numbers, how much can we accept with our current design? 5 digesters at 83 tons each. When the digesters have reached capacity, our estimate, and again, this is modeling because we've never done this before, I don't know that anybody's done it at this scale before, is that we can take another 200 tons a day at the treatment plant. So total capacity with our current facilities that are just about built out, 615 tons a day. The plan is to stay there. Maybe years from now, if the market expands and there's a need for us, we'll move beyond that to more digesters. But this is it for now for the next several years. The third step is energy recovery, and this is for the solid waste department. This is what makes the project viable. I'd mentioned we have different financial models. So wastewater, they charge their customers the cost of operation. Solid waste, we're in a more free market entrepreneurial world. So we in solid waste contract with the haulers. We collect their tipping fees. We pay for the capital improvements. We pay the treatment plant for their O&M costs. On the energy side, we in solid waste pay for design, build, operate, and own the income stream from the energy recovery. I'm going to go back to one more picture of the joint plant because it kind of goes on our choices. I mentioned we have a 20 megawatt digester gas to energy facility you see in the center of the plant, kind of in between the 24 digesters. That plant has a little bit of spare capacity, but not enough spare capacity to take all the extra gas that we're going to be generating from food waste. So we have been using it to make about a megawatt to 2 megawatts of extra electricity in what we've been doing, but we can't build out, they can't take any more gas. We own up at the top a natural gas vehicle public fueling station. This has been, in place since 2008. So this is a commercial CNG station that we own. Clean Energy Fuels operates for us under contract, pays us royalties. So it has been taking natural gas out of the pipeline. There is a pipeline runs under Figueroa Street. So another option is to clean up to natural gas specs and put it in the pipeline. So that's kind of a visual of the options going through. So, what are the options for power? Again, our first phase, we're looking at about a third. We have 200 tons of food waste. We expect 600. Our first phase, we have the gas now from the 200 tons. What are we going to do first? Power, we're using some of the gas, as I mentioned, in the existing power plant, but building a new power plant is expensive. It has smokestacks that need permitting, and it's really not economical for the amount of gas that we have now. So we X that out. Pipeline injection, the same thing. Expensive to build. At the small size we're looking at, it didn't make sense. Vehicle fuel, again, I have slides and make it look like it was a tough decision. It was really a no-brainer. We own a vehicle fueling station already. We can just feed that with fuel made from our own digester gas. Uh, Plus vehicle fuel specifications. If you put in the pipeline, you have to meet gas company specifications, which are 99% methane, very low impurity levels. Vehicle spec is 89% minimum methane. They tolerate a few more impurities. So basically, it's a much more cost-effective option to put in, and most of our infrastructure was already there with a fueling station. So we went with our biogas conditioning system. We're calling this phase one. The phase two energy project is what we will build when we get more gas. Finished up a few months ago. We did a design build contract with Tetra Tech using their BioCNG as their subsidiary that puts together and markets these skid mounted cleanup systems. It's a single pass membrane filtration. We use our own fueling station. How does it work physically? You put in gas at 62% methane through a membrane. The CO2 pushes out. You get a minimum 90% methane, and you've got to clean the gas, dry it. It's obviously not quite that simple, but the core of it is pretty simple. How does it work financially? This is the key. There are two major programs that have basically rewards and subsidies and incentives for putting renewable natural gas into vehicles. One is the California Low Carbon Fuel Standard. This is a standard that all the fuel in the state has to have a specified emissions of pounds of CO2 per gallon of fuel. So it has basically you get an index each case. Basically the well to wheels carbon impact of your fuel. The RINs is the Federal Energy Act. I think it was 2005. This was a law originally intended for ethanol fuel, but they had a part in there about research fuels. If you can remember the second President Bush talking about switchgrass being cellulosic fuel. Well, it turns out that landfill gas and sewage sludge are also cellulosic fuel, so they're rewarded very highly under this system. The natural gas at the wellhead today is about $3 a million BTU, or 50 cents per gallon equivalent put in a vehicle. The full value of all of these credits and the fuel and what you charge a vehicle is on the order of $30 to $40 per million BTUs right now, or $4 to $6 per gallon of fuel. So how it works is these incentives. That's how it works financially. This would not work if we were just displacing $3 a million BTU natural gas. Getting the gas there actually was another $3 million project because we had to get the gas across the street. So this is kind of a schematic of the taking the gas off the digesters. One of the engineering challenges is that these digesters operate at very low pressure, 15 to 18 inches of water gauge, and they all feed that power plant that's in the middle of the treatment plant. And you can't just put in a straw and suck more gas off at vacuum. So a key part of this project was modeling and design of the entire low pressure gas collection system at the site. And kudos to our engineering design group who did this, and it worked just perfectly, almost no glitches when it started up. So that was a success. We've got gas to our system. Final overview with some of the numbers. The gas comes in from across the street. This picture is nice because it shows the storage tank, which is our RNG in the storage tank. Inside the wall here is the existing compressor that takes natural gas from the pipeline, and then the fueling station right there. So the design on this is Our system runs intermittently as needed to fill our tank up to pressure. The compressors run as needed to fill their small storage tanks to keep 3,500 pound pressure for the vehicles to fuel. And basically, as long as we have enough gas in our storage tank, it will pull gas off of our storage tank rather than from the pipeline. The operational, again, we had a startup. I'd mentioned there's so much money in the LCFS and the Renewable Fuel Standard or the RIN registration that early on, there was so much money, there was fraud. Apparently, I heard a story that there was an ethanol plant in Florida that got tens or hundreds of millions of dollars for credits before it was discovered that the plant didn't exist. So the verification process is lengthy and complex, and we hope to have full operation in a couple of months where we're able to put all the gas in and fully monetize that. We, you know, that's it. Moving on, last slide. So the next phase I'd mentioned that we're using about a third of the gas we have as potential. So we're looking at phase 2 energy recovery, and we've got our feasibility studies done. Options, the pipeline injection is a good option. There's a market out there for renewable natural gas. The project pencils out financially. That $8.7 million, if you were doing the same project in Georgia or Oklahoma or Ohio, it might be closer to $3 to $5 million. We have very tight specs here. We also have very tight interconnection standards. So, there's rebates on some of this. These are all pre-rebate prices, but it's a long road to get there. Power generation, again, both of these they'll pay back. There is a feed-in tariff in California up to 3 megawatts that pays about I think 12 to 13 cents a kilowatt hour. So again, those projects pencil out at that. The challenge on power generation is it's got a smokestack. No matter how clean it is, you have an air permit, and that's an issue. Pipeline injection, there's no smokestack. It goes into vehicles that already meet emission standards or somebody else is using it with their permit. The most lucrative would be to get additional renewable natural gas for our vehicle site. We're doing 1,400 gallons a day right now. We're sized for 2,000. If we could, we have the space. If we built a fueling station and could fuel 5,000 or 6,000 gallons a day, that is the most lucrative for us. But the challenge is there's just not that many trucks out there, so we don't have that as an option right now. If we were able to get a partnership with a fueling or trucking company, then that's still an option. So the considerations, market risk, it's a lot of money. This has to come from solid waste. We can't raise taxes. We have to, we don't have much tolerance for risk. Things like operational cost, utility, permitting, those all factored in. But what's holding us up right now is the food waste supply. I mentioned we have 200 or so tons a day of food waste coming to us. There's no enforcement on the state law until next year. All of our contracts are 12-month contracts, so we do not have certainty. So we're not, as an agency, ready to invest this kind of capital until we have more certainty that we're going to have the gas to feed that. And that's it. With that, I'll be glad to take any questions.
Okay, thank you so much, Mark. We really appreciate you sitting down with us today. Now we're going to open up for questions. If you have a question, I see some people have already typed it in, but if you have a question, just type it in on the left-hand side of your screen where it says attendee chat, and Mark, you can just go through and answer them at your own pace.
Sure. I'll just go to the top.
Yep.
Okay, great to be here. Thanks. I can't hear the sound. I'm too late to help you on that. We'll look for, will we be getting the slides?
Yes,
will the
we will.
Academy, okay, so the Academy will make them available, or you can email me.
Mm-hmm.
So question, are the trucks being powered by the biogas in the gas or be converted into liquid fuel? So we are making a gaseous fuel. So the trucks are fueled on compressed natural gas. In California, trash trucks over the last 10 to 20 years have gone from being the dirtiest trucks on the road to the cleanest trucks on the road. They've been leading that. So they're not, so the vehicles at our fueling station at the treatment plant are some trash trucks. A lot of people still have natural gas fired Honda Civics, airport shuttles, buses. So there's a lot of clean fleets in California that are using that. Okay, are there distances to what can be covered by the truck due to the low energy content? Um, there are, it's not, again, I don't know the exact numbers. Um, Actually, there is no CO2 in the gas. So the energy content of what we put in on a BTU per pound basis is actually higher than BTUs per pound of gasoline or diesel. The challenge is the volume because it's a gas, so it's not as dense. So there are some losses in distance, but again, in California, these fleets have been running for a long time. It hasn't been an issue. My agency car for several years was a Honda Civic. It I could go 250 miles between fills, but half of my trunk space was given up to the gas tank. Um, what energy use sources used for mixing and pumping? The electrical pumps at the treatment plant is actually renewable power we generate on site from our digester gas. Electricity agency-wide, we buy from the grid, and we buy a California mix that's 33% renewable. Mixing of the digesters, we actually use digester gas as a mixing agent, so that is pumped or compressed again using site electricity that's renewable. Got Thanks. You're welcome. Um, so Wendy's asking, with California's ambitious diversion goals, is there funding available to make the program cost effective to member cities? Uh, there are so many diverse funding things out there. I don't know that we have funding directly to the cities. There are I know that Los Angeles County, we are not the county public works, has been subsidizing tipping fees for some of their franchise haulers to um, to bring food waste to our Puente Hills MRF. Largely, the cost of this is going to end up on your trash bill as a resident. The cities have, for residential, they have contracts with franchise haulers. The franchise haulers are going to want to pass this through. I can tell you, in Southern California, largely because the sanitation districts built the Puente Hills landfill back in the 50s, our trash rates are very low. It's a competitive market. There's a lot of private haulers. I live in Orange County. I did pay $14 a month for trash collection. Our city just contracted with our local hauler to take food waste. So now I can put food waste in my green waste bin, and that raised my trash fee from $14 to $17 a month. So that's it's a few dollars a month per household, and I think it's going to end up with uh, with the residents. Building these facilities is tough because we take on a risk. So we have received about $6 million in state grants to help build that. And that's, I think the state grant funding is more important to help get this infrastructure built because it's a lot of stuff that has to get built. You have people like cities or wastewater agencies that might be building this at a wastewater plant. It's a new business and they can't take on the risk. What is limiting the 30% food waste to sludge during the bench testing? I the short answer as a mechanical engineer, one step removed, is that higher than that, it messed up the biology. And I think I've heard phrases like volatile fatty acids, but if you email that to me, I can send that to our wastewater people because I've heard the explanation and I don't remember it. How does the pandemic impact your business, if at all? And does it portend changes going forward? We had a drop of about 10% from the pandemic. We've lost another 10% from, to be honest, from competition. Another facility in the area opened up. You know, trash flow in general is down from the pandemic. Roughly, uh, roughly a third of trash is residential, which does not change with the economy. It didn't change with the pandemic. A third of trash is commercial, and that dropped significantly from the pandemic, and that tends to drop a little bit with the economy. Another third of the trash is construction and demolition, and actually in California, construction is booming. People, especially residential construction, everybody's staying home and having time, and instead of taking vacation, remodeling their house. So we have not seen major changes and don't see them going forward. Um, got enjoyed comparing my lessons to yours. Thanks. Vehicles have to be specifically built to use natural gas. It is an internal combustion engine, but you have to repower it. There are no dual fuel natural gas or gasoline engines. One of the battles in California, with the emergence, we have been pushing, excuse me, and our air regulators have been pushing CNG vehicles for decades. And we're there. We're ready. The heavy duty fleet is there. Buses are largely there. Clean Energy Fuels, there's other players. Trillium are working with truck stops across the country to put in natural gas fueling. Cummins has developed an engine that is ultra low NOx, that is 1/1000th the NOx emissions of a 1970s diesel truck. So it's near zero emissions. The battle, the battle in California is that our state wants to electrify, and is there a place for is there a place for renewable natural gas and CNG fired vehicles? And that's a battle that's playing out in California right now. Let's see, next one from Sharon. Are we feeding the feed waste now, and what major we're feeding the feed waste now. The major challenges, I just say it's a lot of small challenges. Finding pump materials that don't get chewed up by the glass, finding the best odor control system that works, making sure, it's, so again, it's no major challenges. It's just incremental challenges that you have with any mechanical system that you start up. Question, was there a difference of the quality of digester gas? I don't remember that being an issue, so if there was, it was not significant enough for our wastewater research people to flag it or to tell me about it. One of the concerns, you saw a nitrogen speck on there. There is a concern that food waste with protein will have more nitrogen and thus more ammonia in the digester gas. So that's a concern that it could disrupt the biology. It's also a concern for any combustion device, our existing power plant or flares, that if there's more ammonia in the gas, when you burn ammonia, it tends to go straight to NOx, nitric oxide. So there are concerns on, will that impact NOx emissions? And we're actually, it's been a paper study so far, but I've got one engineer who does a lot of research on his own. So he's going to be going out there actually this month and taking samples. So we'll know if that ammonia increases there. What substrate to substrate inoculum ratios? So I'll talk in. I don't know what inoculum is. I'm not a wastewater guy. So the numbers before, it's 30% solids. So 30% food waste out of 100%. So 30% food waste, 70% biosolids on a solids basis, 9% food waste slurry, 91% digester sludge on a liquid basis. Comment. So municipal agencies are finding challenges with the business side of resource recovery initiatives. Can you shed a little more light on how we're structured and what type of non-traditional staffing was included to help with assessing markets, projecting revenues, and pricing? So again, we are on the wastewater side. We have we go back to the 1920s when LA County was growing like crazy, and some cities were just dumping stuff in the creek, and city of LA was just piping it to the ocean, and people had septic tanks. So there was actually a state law that created us, the Sanitation District Act. So we have, 88 cities, 25 districts. I never remember the exact numbers. And we're basically a special purpose district that we set our rates based on cost of use under California law. Anytime a government raises its rates, we have a public noticing system. So we look at our cost of operation. We set the rates every 3 years. There's a lot of people involved in that. And, they do capital planning. The solid waste side, I mentioned, we do not have the power to tax. We're not a city government. So where a city of Philadelphia or New York, to name a two, they can have an edict to be sustainable and digest food waste, and they just raise taxes to pay for it. We don't have that option. So everything we do, from receiving trash at our landfill, at our material recovery facilities, getting the food waste, we have to compete and market. So it's entrepreneurial. To be honest, we're not, we're not making profit. Nobody's getting rich. We're not driving Teslas. We're driving Chevy Bolts, but we do need, because of the competition in solid waste, we provide a service to our cities, and we need to keep and direction from our board is we need to keep our solid waste operation group economically viable. So, the non-traditional staffing is that, I don't want to say we have non-traditional staffing, but basically we have engineers who are sharp, who step outside of their box. So we don't even have a chief financial officer to be, our financial management group is run by a departmental engineer. So we have people with various skills and backgrounds. I spent 20 years in consulting. We as an agency have built a lot of power plants. So, as an agency, historically, we know how to financially design something that's going to be fully funded by ratepayers and run for 100 years. And we know how to financially design something that we've got to find the money for and might only run 10 years and has to pay back in 5. So basically, the non-traditional staffing is the expertise of our staff. And again, we have, my section, the energy recovery engineering section, is we do a lot of things like that. We're kind of nimble. We design, build, and run power plants, but we're also kind of unique in our agency org structure that we have the ability to be brought in on opportunities by food waste and have the staff and develop it start to finish. So I guess that's the answer. And there's no shortage of consultants out there who can who can help you on that also. David Haug, how many of the district's vehicles were converted to use this system? We've actually, we didn't convert any vehicles specifically to use the system because the system has already been running on pipeline natural gas for 10 or 12 years. We've, over the years, converted, for a long time, all of our fleet vehicles were CNG. We still have several of those running. Basically, wherever vehicles were available over the last 10 or 15 years, wherever something commercially available, we converted. So we have a fleet, I think, on the order of dozens of vehicles of light-duty trucks, Honda Civics, and then on the trash hauling side, we bought 35 new semi-trucks for when our Puente Hills MRF started up, and those are on natural gas. So on the order of dozens. When do you work? Thank you. Is there any impact due to the trends toward electric vehicles, future plans and projections? So that impact is uncertainty. When I mentioned the renewable premium for renewable natural gas right now is mind-boggling. To think that it's $3 a million BTU for brown fuel and $40 for renewable fuel. Whereas on the electricity side, that's where they were 20 years ago. But now in California, natural gas is 3.5 cents a kilowatt hour, and you can get 25-year renewable or solar contracts at 3.5 cents a kilowatt hour. So that margin is not sustainable. And that's reflected in that this is all short-term market. So there are long-term contracts on the order of $10 a million BTU for this gas. The trend toward electric vehicles, and that's part of our decision process, because if you're a private developer at $40 a million BTU, but that's this year's price, there's no long-term contracts. You can't go to the bank and get financing, but you can go to the business equivalent of payday lending and get your own money, and you got your plant paid off in 14 months. We don't move that quickly, and we're going to be around. So we're looking for something that's going to be around for decades. And to be honest, it's a concern that we're talking about in California. Is there going to be a market for vehicle CNG in 20 years? Do we build something with a 4-year payback that's going to be obsolete in 20 years? So that's something that we don't know, and it's going to shake out in California. Again, as an engineer and looking at life cycle balance and impact on the environment, my personal opinion is absolutely long haul trucking is the best market for CNG. These trucks are clean, heavy duty trucking. Electric trucks are not there yet. Maybe they'll be there, but the RNG distribution system is there now. The truck technology is there now. We can go there today. To build the infrastructure of 100% electric vehicles in California is really a decade or more away, and a huge expense to do that. So, and I apologize if I'm wandering a little bit on these answers. You get more depth than you have. Isaiah says, thank you. Thank you. Paul Shaw says, used to live in Huntington Beach and went to UCI. Great job. Again, as one of the oldest Anteater alumni out there, I thank you, and still proud to see our university going. Last question, do we use a third-party broker to handle our credits? Yes, we do. The credits are, and do we let the market govern the value of the credits, or do we have a fixed value agreement? We're floating with the market. We have actually two groups of third parties. So the LCFN and RIN credits, and again, we have, basically, you've got to get a consultant who navigates a system, gets you the pathway, gets things certified, people verify they expect. So those are consultants that we hire separately to get to where we're now ready to go to market. What we have done on our contracts to date is that we have contracts with our fueling station operators that they sell the credits and we get a percentage. So we have two stations. The existing station we have in Carson that's taking our gas, and we're looking to expand. I'll say that the other thing I'll say, if there's $4 worth of credits and the gas costs you 50 cents and somebody pays $2.50 to put it in their tank, whoever owns that fuel has $4 to make. A lot of the truckers are getting their fuel for zero or near zero just because you need the truck. So, somebody owns a gas, whether it's us or a landfill, somebody, upgrades it, somebody puts it in the pipeline, somebody does the credits, there's a broker, somebody takes it out of the pipeline, somebody runs a fueling station, somebody puts it in their truck. There's about 7 entities in that chain, and my experience is that every entity wants 50% of the money. My experience commercially in that where we own one part of the chain, we get 5 to 9% of the money, and where we own all of the chain except for one, we get 80 to 90% of the money. But our contracts, we have the entity that operates our station handles the credits and pays us a royalty. How were we able to get our food waste so quickly? I'd mentioned SB 1383. There were actually some other earlier rules for commercial recycling that required large trash generators to start source separation. So that was the market that we have. So quickly, we started early. We did the program with Waste Management. They've continued as a customer. I've been giving presentations on this for 8 or 9 years now. We're out front in having things that are commercially available. So, a lot of people were basically in the last few years getting the food separation. It depends on the customer. You saw that truckload that looked like a salad bar. That's a grocery store or a produce market with expired produce. It's pretty easy to do that. The smaller you go, when you go to a restaurant where you have to train staff to separate food waste, that's a lot harder when you go, so we are basically taking the low-hanging fruit right now, and it's going to get harder and harder as you go to smaller and dirtier streams. And that is it that I see for questions. Thank you, everybody, for attending. Again, my email was there on the last slide. Feel free to contact me with any further questions.
Thank you so much, Mark. Also, I wanted to point out that our next webinar is on March 25th, and it's going to be on COVID wastewater sampling. So stay tuned for more information on that. Again, thank you, Mark, and everyone enjoy the day.
Thanks, everybody.